Hello, everyone, and welcome to the Trenchless Technology webinar series. My name is Mike Kesdy, Associate Editor for Trenchless Technology, and it is my pleasure to introduce our presentation, Spiral Wound Liners Leading Edge Technology. We're going to take a quick poll, so please submit your answer and then click the blue Return to Presentation button. As a reminder, any views or opinions presented in this webinar are solely those of the presenters and do not necessarily represent those of Benjamin Media, Inc., nor does Benjamin Media, Inc. endorse any products or methods presented. Presenting today is Sean Melville and Klaus Langenbach of Sekisui SPR. Sean Melville has been with Sekisui for 22 years, initially as a civil engineer for direct bury pipe applications, but most recently as General Manager of Rehabilitation. He oversees manufacturing, quality assurance, and plant maintenance departments in addition to engineering duties. Sean is a member of ASTM F17 and ISO TC 138/SC8 for standards development relating to pipeline rehabilitation. His background is in civil engineering, where he earned his degree from Adelaide University in Australia. Klaus Langenbach has been with Sekisui for 16 years. Starting as a project manager. He later became company director for Spiral Wound Liners in Asia before becoming vice president of operations for SPR Americas here in the United States in 2015. He has 21 years experience in the pipe rehab industry, starting at Canal Müller in Germany in 1997, while spending most of his career in Singapore and Hong Kong since 1998, and in the U.S. since 2015. He holds a chemical engineering degree from the University of Karlsruhe in Germany. Following the presentation, there will be a question and answer session. We encourage you to participate by typing your question into the designated panel in the left-hand portion of your screen. You can also maximize your viewing window by clicking the box with the X at the upper right of the slides. Now please welcome today's speakers, Klaus and Sean.
Well, thank you very much, Mike. My name is Klaus Langenbach, and we're very honored to present to all of you spiral wound liners, which we believe is a leading-edge technology. Thanks very much for everybody participating in today's webinar, and we're looking forward to receiving questions throughout the presentation, which we will then answer in the Q&A session afterwards. Today's presentation outline will be gravity pipeline rehabilitation, a short introduction there before I pass over to Sean, who will then go into the technical details of the presentation, and he will cover an overview of the technology, go into design considerations, talk about features and benefits of the spiral wound liners before we go to typical installation case studies. As you know, we have a couple of trenchless technologies available in the market. CIPP is probably one of them that you all heard about. We have pipe bursting, slip lining, spray-on lining like the epoxies and geopolymers. And today's presentation is really about spiral wound liners only. And I'm handing over to Sean now.
Good afternoon, everybody. Now, we're going to be focusing primarily on machine wound spiral wound liners. There are other techniques hand applied, but again, for this presentation, we're primarily going to focus on the machine wound liners. So we're going to talk about the history of spiral wound liners, a brief process description of the various options, describing the PVC materials and the installation methods. Following that, we're going to talk about design considerations, features and benefits, typical installation, and then we'll hand back to Klaus to talk about some of the case studies. So a brief history of spiral wound liners. There's approximately 30 years of installation history. The technology originated primarily out of Australia and then Japan in the 1980s. We first introduced the technology into the United States in 1996, and around the world we've got approximately 20 million feet installed and 3 million feet installed within the US. Spiral wound providers, obviously we have Sekisui SPR Americas. Within the US we have Contec Engineered Solutions for the PE liner product. There are other spiral wound technology providers such as Danby Pipe Renovation and SWP. Now, on spiral wound liners, the technology involves a PVC or a HDPE profile strip with a continuously sealed spiral joint. It is extruded in a factory environment and then shipped to site, and some of the technologies have optional steel reinforcing strips for fixed diameter and some close fit solutions where additional structural strength is required. In the factory, we extrude the profile and we spool it onto large drums, which are then transported to site. The spools are located above ground and they're powered on driven skates, hydraulically driven, and the profile comes from these spools with the different technologies and is fed through manholes to the machinery which is installed in place. The winding machines that we're going to talk about primarily today, we have 3 different machines. We have an SPR EX machine. The range of that is typically between 6-inch and at the upper end 42 inches. We have an SPR TF machine, which is a machine that traverses the pipeline and lays a liner behind it. We also have an SPR TM machine, and a particular machine shown here in this slide is also a traversing machine. So we have options where we can install from a static machine in the base of a manhole, pushing out a liner, or we have the machines that traverse the pipeline, leaving the liner behind them. There are close fit solutions, and there are also fixed diameter grouted solutions. The installed liner is a hydraulically sealed, fully structural pipe. The smooth inner surface of a plastic liner provides improved hydraulic capacity. The loss in cross-section is typically countered by that improved flow capacity characteristic, and we typically design for a 50-year design life. Now, the PVC profile. It's a UPVC material. It meets the minimum cell classification requirements within ASTM F1697. There are a few different profiles which are covered by that particular standard, depending on the particular application. The PVC profiles are sealed via a mechanical lock. Now, the sealant materials are primarily factory applied, and the QA for such a PVC profile is really done in the factory, and the benefit of this is that it's a mechanical installation process. There's no thermal processes and so on going on site. The PVC profile does vary with the installation method. The particular profile that's shown on this particular slide is for the SPR TM method. And in any case, there are options with and without steel reinforcement. There are particular profiles that are designed for close fit, expandable applications. There are also profiles designed to be laid in close contact with the hose pipe as the machine traverses the line, and profiles designed to be installed at a fixed diameter, in which case the annular space between the liner and the hose pipe is grouted. The mechanical lock in between each successive wrap of PVC profile. There's a sealing material that is factory applied. In the case of the SPR EX technology, there is lubricating sealant applied on site. At any rate, the liners are designed to prevent any infiltration. They have passed the requirements of various standard requirement tests for pressure testing. This next example for SPR TF profile, what we have here is one of the examples that is a PVC only profile. There is an option for SPRTF that does include steel reinforcement for a greater long-term stiffness. Once again, this particular material can be steel reinforced. It is an expandable product. It can be laid in close contact with a host pipe. Now, the difference between the different technologies, it was mentioned before that we have the option to place a machine in the base of a manhole and essentially push out a liner, so a fixed machine. In effect, this is more or less an advanced form of slip lining, in which way we are able to push out a liner and then, through a mechanical process, radially expand it to form a close-fit liner with the existing host pipe. So the winding machine is placed at the entry point of the host pipe at the bottom of the manhole. We wind profile through the machine to push out a liner pipe in either direction, upstream or downstream. The traverse winding method employs a machine that we place at the beginning of a line, and it forms a liner as the machine travels the length of the host pipe, simultaneously interlocking the profile to form the liner. The PVC profile is pulled and winding occurs within the pipe.